So in this video, let's talk a little bit about exponential notation. Now, what that really is just a shorthand for repeated multiplication. And so if we're going to do something like repeated multiplication, there's really two things that we actually need to know. The first thing is what exactly is being multiplied, and that is called the base. The second thing that we actually need to know is the number of times that we're supposed to multiply, and that is called the exponent. Now, how we typically write exponential notation, we wrote the exponent as a superscript, and then we write the base as a subscript. And so when we are, what this notation is actually telling us, the base, 3, is what's being multiplied. It's being multiplied a total of 4 times. So 3 with the superscript 4 on it means 3 times 3 times 3 times 3. And if we multiply all those 3's together, we get a grand total of 81. Now, when we're writing that, we need to be able to translate that into some kind of English phrase in our head. And so when we see this 3 with the superscript 4 on it, we would usually say that as 3 to the 4th power, or we'd just say 3 to the 4th, something along those lines, so that whenever you are seeing that notation, you are getting the right English phrase in your head of 3 to the 4th, or 3 to the 4th power, being 3 times 3 times 3 times 3. So let's do an example, and suppose somebody asks us to evaluate 2/3 to the 5th power. Then how do we actually go about doing that? Well, we can go back and think, what does it actually mean when we write down 2/3 to the 5th power? Our base is going to be 2/3. That tells us what we're actually going to be multiplying. And the 5, the exponent, tells us the number of times that we're going to multiply. So we're going to have 2/3 times 2/3 times 2/3 times 2/3 times 2/3. And if we kind of count the number of times that we are multiplying, that gives us, sure enough, 1, 2, 3, 4, 5 times that we're multiplying 2/3. And now we stop to remember, well, how do we actually multiply fractions? Well, we multiply fractions straight across. So we're multiplying numerators, we're multiplying denominators. So we get 2 times 2 times 2 times 2 times 2, 3 times 3 times 3 times 3 times 3. And kind of over here as a little bit of scratch so that you can see how we actually come up with that. We've got 2 times 2 times 2 times 2. I can take them in pairs. 2 times 2 is 4. 2 times 2 is 4. And then I got my extra 2. 4 times 4 is 16. Times 2 gives me 32. 3 times 3 gives me 9. 3 times 3 gives me 9 times my 3. 9 times 9 is going to give me 81 times 3. Now for the 81 times 3, I can kind of break that down as 81 being 80 plus 1. And so 81 times 3 is going to be 80 times 3 plus 1 times 3. Well, 3 times 8 is going to be 24. So 3 times 80 is 240. 3 times 1 is 3. 240 plus 3 gives me 243. And so if we want to go back and kind of put all of that together, now if we want to evaluate 2/3 to the 5th power, what that's going to be is 2/3 times 2/3 times 2/3 times 2/3 times 2/3. So 2/3 multiplied by itself 5 times. We multiply numerators. So 2 multiplied by itself 5 times gives us 32. 3 multiplied by itself 5 times gives us 243. And so our final answer is 32 over 243. And so we can ask ourselves, how exactly does exponential notation interact with negative signs? What we need to remember is that the negative sign really means that we're taking the opposite of a number. And so the opposite of really just means that we are taking the number that's the reflection across 0. And so if we would write down something like -2, we really mean that that is going to be the opposite of 2. And so on our number line, we get a picture that looks something like this. We're seeing 2 over here, and so the opposite of 2, we have 2 there. If we do a reflection across 0, that lands us on -2. And so if we kind of did the opposite of 3, which is what we have here, so the negative of -3 is going to be the opposite of 3. So what that's going to be is going to be the opposite of 3 puts us over here at -3, and so the opposite of 3 brings us back around, so we do another reflection and we end up back at 3. And so what we have then is the opposite of 3 is 3. Now in this case, suppose we have negative of -4. Well, what that is really, we've got the opposite of 4. And so we get a picture that looks like this. So we've got the opposite of 4 putting us over to -4, the opposite of 4 bringing us back to 4, and then the opposite of 4 bringing us back again to -4. And so what we really have is that the opposite of 4 really gives us -4. And so how does this actually work once we start including negatives with exponents? Well, we remember that the opposites actually go with addition and subtraction. And so when we would write something like -2 to the 4th power as being the opposite of 2 to the 4th power. So what that really is telling us to do is to do the multiplication first. So we would do 2 times 2 times 2 times 2. So our base is 2 raised to the 4th power. We multiply 4 times, and then we take the opposite of that because multiplication is going to be done before addition and subtraction in our order of operations. And so -2 to the 4th power is going to give us a -16. So how would it work if we actually wanted to include the negative in the repeated multiplication? Well, we do that by putting a grouping symbol. So we're going to put parentheses around that negative. And so if we wanted to include the negative in the multiplication, we would do parentheses around the -2 to the 4th power, which is going to tell us to multiply the opposite of 2 4 times. So we've got -2 times -2 times -2 times -2, giving us -2 times -2, giving us a +4, -2 times -2, giving us a +4, 4 times 4, giving us 16. So a -2 with parentheses around it to the 4th power is going to give us a +16. No parentheses is telling us to take the opposite last, and so we do the exponents. The exponent is only attached to the base of 2, and so we have a -16 when we don't have parentheses. So that's kind of an important distinction to be aware of. And kind of a subtlety in how we're kind of reading our mathematical notation. So this is something that we definitely kind of need to be aware of and committing to memory. That these two things give us different values, or that they actually are meaning two different things. And so kind of as one last example, how exponential notation looks with decimals. And suppose we have 2.1 to the 3rd power. Well, again, we go back to what we mean by 2.1 to the 3rd. That's actually going to be our 2.1 times 2.1 times 2.1. Our base being 2.1, the exponent telling us the number of times that we're going to multiply. So we have 2.1 times 2.1 times 2.1. So kind of taking these in pairs, 2.1 times 2.1 is going to give us 4.41. So we've got our 4.41 times our 2.1. Now we multiply that, and 4.41 times 2.1 is going to give us 9.261. And so just kind of a little bit of a review, if we're multiplying our decimals, 2.1 times 2.1, we've got 1 times 1, 1 times 2, then we move over one decimal place. So 2 times 1 is 2, 2 times 2 is 4. Now we're adding straight down, so 1, 2 plus 2 is 4, 4 we have there. Then we move over a total of 1, 2 decimal places. So 1, 2 decimal places gives us 4.41. 4.41 times 2.1, same procedure. We have 1 times 1, 1 times 4, 1 times 4, 2 times 1, 2 times 4 is 8, 2 times 4 is 8. We add those together, 1, 6, 12. We carry the 1. 8 and 1 gives us 9. We move our decimal point over 1, 2, 3 places. So 1, 2, 3 places gives us a final answer of 9.261. So 2 to the third power, 9.261.